So, and one of the things that we need to really be aware of is if we're going to be defining a function in a file, anything that comes after is not going to be executed. So really, realistically, when we're writing a function, we should in MATLAB have the file name be the name of the function. We'll get a warning saying, you know, careful, your file is not called the same thing as your function name is. But for now, this is okay. So all I've done here is I've just commented out some of the other things. And here we have the function square plot. We have y equals x, and then the dot square operator. I'm going to put a semicolon here because I don't want to see the values. Now, this doesn't clearly specify that x has to be a vector. We haven't said that x has to be a vector. There's not a way to indicate that in here, but here we have used the vector square operator, which means we want to square the elements of x. But it's nothing keeping from somebody from entering in the number 5 for x. Okay, so once again, what we have here is, just to recap, we have plot, what our x-axis vector is, what our y-axis vector is. Now, I could have called this w, right? Then this doesn't have to be called x and y. What we call variables is totally up to us, but if we like to stick to conventions, we might use x and y. All right, so in this case, I want to plot x on the x-axis, w on the y-axis. W is going to be the squared elements of x. What it's going to do is it's naturally going to pair the values in the vector x with the values in the vector w. We want to do that in red. We typed in hold on to indicate that we're going to add some features to the graph, so don't plot it yet. We had an X label inside of you could either use single quotes or double quotes. It really doesn't matter. It's better to be consistent, but I'm just using double quotes here. I'm just typing in x-axis. I could type in whatever I want here. There's nothing stopping me from just saying goodbye, hello and goodbye. And then the title, I can put in there whatever I want as well. Now there is a way that you could actually have the user pass in also what they want the X label and Y label axes to be called, but in this case we're not going to take it that far. Okay, so we save that. We have everything else commented out. Remove that. So that's all we see in the function. Now when I click run, it's going to say, okay, what do you want to input for X? All right. Well, what do I want to input for X? I think I want to input the number 1. What's going to happen if I do that? Okay. Well, in that case, it still works out, right? It still has an x-axis label of hello, y-axis label of goodbye. Title is called this is the title. It's done in red. It's only a single point. So it's the point 1, comma, well, it should be 1, comma 1 because the output value is getting squared. So if I run this again, I can now enter a whole list of values. Okay, if I want to do that, let's see what happens if I do this. 1, 2, 3, 4. Well, it didn't quite do what I was expecting. And here we get that warning saying function name square plot does not agree with function file name. Oh well, not too important at this point. So notice it only still just gave me that one ordered pair. So in order to actually make this a list, I would want to put the brackets around it, right? Because I want to say I want the square of all those values plotted. And when I run that, now it does it. And there are, okay, so I get 1 squared, I get 2 squared, and then it's connecting all those dots. One other thing I can do to define a list is let's say I just want the numbers 1 through 4, or maybe I want the numbers 1 through 100. So what I can do is I can do 1 colon 100. And what that does is that just says, give me all the elements between 1 and 100. Okay, so I run that, and now it gives me all the x values between 1 and 100. And if I look at the variables that have been created, there are none, because this function only temporarily creates those variables, and then once it creates the plot, its job is done. So those variables are no longer stored. If I also wanted this thing to give me the values of w, for example, and I can now put a return in here, say give me the vector w once it's been defined. Okay, all right. Well, there's a bunch of stuff happens. So it actually outputted w, which is the square of all the x values. So 1 squared is 1, 2 squared, 3 squared, 4 squared, 5 squared. It's very ugly the way it appears. But basically what this has done is it's returned the values of w in addition to creating that plot. Okay, so there's that plot. So that being said, another thing I may want to do in here is maybe I really just want the numbers 1 through 4. Okay, so quick way to do that. So there we go. W is 1 squared, 2 squared, 3 squared, 4 squared, but I don't like how jagged this looks. What I actually want to do is I actually want to have the numbers 1 through 4, but I actually want increments that are smaller than by ones, right? Because by default, if I just type in 1:4, that's just going to give me the integers between starting at 1 and ending at 4. But maybe I want them in increments of let's say a half. So if I put another colon in there, so I have colon, colon, and then in the center of that I put in 0.5, what this actually means is go from 1 to 4, but go in increments of 0.5. So if I run this now, notice that the vector w that's returned, that's 1 squared, that's 1.5 squared, that's 2 squared, that's 2.5 squared, that's 3 squared, 3.5 squared, and 4 squared. And I get something that looks a little smoother, right? Because now it has fewer corners because I'm going in increments of a half. I can change that even further. I can say, you know what, give it to me in increments of 0.1. So now I'm going to get about 40 values. Let's see. 31 values here, and notice that I start getting a much smoother looking curve because what's happening here is those ordered pairs are just being connected with straight line segments, and if those ordered pairs are really close together, then the approximation is going to be much closer to a curve. So that's something that you could do with vectors. You can, same thing. Let me remove this function now that we're done with it, and let's say what I want to do is I would just want to create a vector that's going to be 1 through 10, but I want the increments to be in units of 0.25. Okay, close my vector back here, save this, run this. So now it's showing me all the values between 1 and 10, and you can see that all of the numbers in there are spaced by a quarter. That saves me so much work. I would normally have to go in and type in all of those units, but here I can just specify what I want my step size to be, what my starting and what my ending values are. And I can do any functions I want on this thing. I could say y equals, I don't know, maybe I want to do 3 times x. Now in this case I don't need to do dot because when you're working with matrices, when you multiply a matrix by a constant, it's assumed that what you're doing is scaling the values. So you can see y is just 3 times all the elements inside of that original. But if I want to do operations like squared, like 3 times x squared, then I have to do x dot caret 2. It seems kind of counterintuitive, but it's exactly what we want. So now basically my x are the numbers 1 through 10 in increments of a quarter, and then my y is 3 times x squared. So now I can do things like, again, plot x versus y. And in this case, if I just do this, just going to generate that plot. So there's the graph of y equals 3x squared. There are many other features of the plot function. If you actually go to the documentation and you type in plot in MATLAB, and so, okay, 2D line plot, let's look at that. Okay, there's the plot function, and you can see that the syntax, it actually gives you all of these like optional things. It might be kind of hard to understand if you're not used to reading documentation, but in this case, like it says, x1, y1 sets the line style, so line spec 1. Okay, what does that mean? Well, these are the different things I can actually do for that third thing that's separated by a comma. So if I have x, comma, y, comma, these are all the different things I can input in there. So I can change the color. Y is yellow, M is magenta, C is cyan, I think that's how you say it. I can also choose my marker. If I want just, ordered pairs, I can do dot as a point. I can have X's on there. I can have diamonds, and I would put a D in there. And you can play around with these different things. You have dash lines, solid lines, dotted lines, dash dot lines. So let's just try a couple of these out. So if I do that, well, first of all, by the way, that's going to give me an error because I need to wrap that in quotes to say that's just the style that I want, and you can see there's a dotted line. I can do a dashed line, and there's lots of documentation out there, so feel free to peruse that, and you'll be able to find much more than we can possibly explain here in a video. But the documentation is pretty good. You can actually also use hexadecimal code colors in place of the letter. So for example, gosh, I really like this purple. I want that. So if I grab that, copy that, and paste it in place of this. I run that. I didn't like that too much. Let's take that away and see what happens. Nope, didn't like that. Anyway, you kind of have to play around with it, but you can feed it a number of different parameters. So I think that's where I'll go ahead and stop this video. Hopefully that's been a good enough introduction to doing different things. And that's how you use vectors, symbols, and the solve function.